Hello everyone, welcome to our channel Sticky Mac. In our last class we discussed very briefly about OSI layers and TCP/IP layers with real-time examples, and we also discussed about examples and how they actually work according to the features of OSI and TCP/IP. So today we'll start from networking devices, that is from layer 1. We'll talk about all the devices that fits into layers of OSI model. So without wasting much time, let's stick to our agenda, what we have for today. So we'll start with a very recap of OSI layers, and we'll also move on to layer 1 devices, and then what is hub, why do we need it, and then at last we'll conclude our class by discussing about working of hub. So saying that, as I mentioned earlier, in our last class we discussed about OSI layers. So I have already written down the layers of OSI as well as TCP/IP. Now, very quickly, let's brush up the concepts. So here, we have the OSI 7 layers. So I would say, going by the bottom-up approach, at first we have a physical layer, right? And then we also have a data link layer, network layer, transport layer, session layer, presentation, and at the top, there sits our application layer, right? So this is our OSI layers, and then towards the right side we also have our TCP/IP layer. So in OSI we have 7 layers. In TCP/IP it depends, how do we categorize it. So usually it's 4 layers. So let me put it in this way. So I would group my top 3 layers here. I'll do this very quickly, and transport layer alone, network layer as alone, right? And I would mix this my data link layer and a physical layer, right? And what I would do is mm, this is our OSI, and now here we have TCP/IP. So what exactly has happened is in OSI, we have 7 layers, and in TCP/IP we have 4 layers. So what we have done is, how did we reduce 7 layers to 4 layers? Is in TCP/IP we have combined together physical layer and data link layer. So now we call it as a physical layer, and then network layers is a separate, and then again we also have a transport layer as a separate layer. But then the top 3 layers that we have in OSI, like application, presentation, and session layer, we group together all of them, and then we came up with the application layer, right? So this is what just to recap on OSI and TCP/IP layers, and very briefly and in depth we discussed in our in our first class of OSI and TCP/IP. So now let's move on. I think now we are done with our first part. So now let's quick really move on to the layer 1 devices. So in layer 1 devices, we have a hub, and also we have a repeater. So when I say layer 1 devices, it's nothing but the devices that works on layer 1, that is our physical layer here, and the protocol data unit that we discussed yesterday, right? So every layer has a protocol, or I would put it in this way, like the data unit or the information, right? How the device deals with that, we call it as a protocol data unit. So for physical layer, the PDU, protocol data unit layer, is bits, right? So what all devices that fits into physical layer, like as we discussed hub and a repeater, these works on our bits, right? So this is the basic info that we discussed in our yesterday's class, and this is just a recap once again. So what do we have in layer 1 devices? We have a hub and a repeater as a devices present in a physical layer, right? So now let's move on, and then we'll try to understand what is hub, and why do we actually need it, right? And then very quickly we'll also discuss about the working of hub, right? And talking about what is hub, so as we already discussed, hub is a network device, and then it is part of our physical layer where our protocol data unit is bits, and then hub was actually designed to group all the devices. So we'll discuss more on this in our coming part, like why do we need it, and then the working of the hub. So, moving on now, let's discuss, the devices that are present in layer one, right? So, here I have a repeater. As I mentioned, we have repeater and we have hubs in layer one device, right? So, what's exactly, I would touch upon repeater in depth in our next class, but just to give you a brief, about what is repeater and how does it work. So I have drawn this picture already for you. So this is how, let's assume, this is our repeater here, and it's a kind of an base station, I would say. And if you are familiar with cellular networks, we have a base station, mobile station. So when I say cellular networks, it's our mobile phones, how they do connect with the towers that we have, right? So those are called as base stations, and our mobile phones are called as mobile stations, and they work upon cellular structure, right? I mean, each area is divided into cells like this, and that is how the range is covered. So what repeater does is, repeater is a layer one device, and let's say all it how it works is, there's an base station, and then if this range, the range of the base station has to be increased, and then this user, let's say this is a user A and this is a user B, right? So now user B wants to access this network, or he wants to reach this network. What we can do is, we can use a repeater here, and what it does is it regenerates the signal, right? So let's say there is a signal coming here, right? It goes to our repeater, and then this repeater, what it does is, it regenerates the signal. So why do we regenerate a signal? So over a long distance, there's an attenuation. So attenuation is a loss of power or a loss of signal, right? So because of that reason, the signals cannot reach to a longer distance. So that is why we have a repeater in place. It regenerates the signal, and then it transfers to the the next cell or the nearby ranges. So this is the functionality of a repeater, right? So now let's move on to hubs. So now let's talk about why do we need hubs? What was the need, that actually, that actually made us to invent hubs, right? So let's assume we are sitting in a lab, right? And then we have all these six machines, and I would like to give you a real-time scenario here. So let's assume we all are sitting in a cyber cafe, and then all these machines need to access an internet, right? So when all these machines needs to access an internet, there is no configuration that is required. All, my basic purpose, or all that is required for me is, all these machines should be connected to an internet, right? So in this case, or in such cases, I can use a layer 1 device called hub, right? So for hub, we don't require any sort of network configurations, right? So hub is a kind of a device which comes with a lot of ports, wherein you can just easily connect any sort of devices, right, which needs to communicate with each other. Let's say A wants to communicate with B, and B wants to communicate with C, or A wants to communicate with D, right? So if you connect all these devices through hub, right, now A can communicate with D via port number 1 and 4, right? This is what, how it happens in cyber cafes, or in, in our college labs. So all these machines that we have in our lab are connected to hub. Then that is why, we can ping each other's machines, right? So this was the need of the hour back then, to group the machines together and then make them communicate with each other. So that made, to invent an hub. So I think now we have discussed most of the points. Now let's quickly jump on to, the working of hub, right? So now let's assume here is a hub, and now we have already discussed about why do we need hub, what is hub, and in which part of the layer it works, and what is the protocol data unit, right? So PDU, or the protocol data unit, or the hub, works upon the bits, right? So now let's understand how hub works, right, in practical. So this is the scenario that I have. So let's assume all these devices are connected to hub, and then mm, now let's understand, or let's mark A as our source, and then uh, F as our destination, right? So now for me the requirement is uh, A needs to talk to F, right? So using hub, we all know that hub is not an intelligent device. Why? Because the functionality of a hub is designed in such a way that hub doesn't understand any sorts of bits or the data that is present in a that is present in a frames. So it lacks that basic set of intelligence, and then it cannot discriminate between the source of information that is present in a packet, and then because of that reason, it cannot deliver the packets to a specific ports. So what do I mean by that? So let's understand, as I marked my source and destination, and as I said, A wants to send a packet to F, right? And now in this case, if A sends a packet, right? So it reaches the port 1, right? Now it reaches the port 1. And we also know that hub lacks that basic intelligence where it cannot discriminate between, or it cannot understand the basic set of information present in a frame, and it cannot say that to which port I need to send it, because it doesn't understand the information that is present. So all it does is it just broadcasts the packet to all the ports that it has except the incoming port, right? So here the incoming port is 1, right? So what do I mean by incoming port? The port through which a packet has entered the hub, right? So such interfaces or such ports are called as incoming port or ingress port or in ingress interfaces, right? So it broadcasts that particular packet to all the ports except the incoming port. So this would be my incoming port, right? So except this port 1, it broadcasts the packet to port 2, 3, 4, 5, 6, right? So now what happens when it broadcasts? This machine also receives the packet, right? This machine also receives the packet. This machine also receives the packet, and so on. All the machines in the network receives the packet, right? So is this what was intended, or is this what the purpose of A was? Like A's intention was to send a packet to F without letting other machines that are connected to hub know, right? So if you understand the overall scenario here, right, there is there is a serious flaw when it comes to the standard principles that we have, or a set of pillars that we have in a information security, right? So in information security, we have something called as CIA triad, right? So what do I mean by CIA triad? These are nothing but a set of principles or set of pillars, you know, that is very much required, to maintain a communication, to maintain the integrity, and to establish a connection, and then make that communication more secure, right? So security, i- as the names suggest, right, information security, we provide a security as a feature to an information where we try to prevent all the attacks, or data leakage and so on, right? So with this set of principles, we prevent such things. So what does C stands here? C stands for confidentiality. and I stands for integrity, and A stands for availability, right? So in our scenario, what makes you think that which principle or which pillar of information security is violated, right? If you know that hub lacks the intelligence and it doesn't know to which port it has to forward the packet, so all it does is it broadcasts the packet except the incoming port, right? So in this case, the confidentiality, which is the basic feature of our communication, right? So we require privacy and we require confidentiality. We don't want others to know what we are doing or to whom we are talking to, right? So this is the feature that is, I would say, mostly violated, right? Confidentiality part of the information security policy is violated. Now let's talk about integrity. Is it violated in this scenario? I would say it can be violated to a certain extent. So now understand how it can be violated. So assume that B is an attacker, right? Who is sitting between or who is also connected to a hub and sitting between A and F, because those are the source and destination. As I mentioned, the packet would come to hub, and what does attacker does is he immediately sees that packet, changes it, and then he sends it, right? As again, hub broadcast the packet, and that packet, right, which is, I would say, modified, right, that would be received by a destination. So in this case, what principle is being violated? Integrity. The integrity of the original message is you know is impacted, right? Now let's talk about our availability. If the same attacker sends a huge amount of a traffic or a huge amount of frames to a hub, and then hub stops working, right? To put it in a very layman's term, hub stops working because it cannot process a huge amount of data at a certain point of time, right? So in that case, the availability feature, sorry for that, the availability feature is also impacted, right? So it all depends upon how an attacker works, or how skillful he is. But nevertheless, let's stick to our point. This is how the hub works. So what all points do we know about hub now? Before we conclude our class, hub is a layer 1 device. It works on the protocol data unit, that is bits, and it doesn't it lacks the basic intelligence, like to which port the packet or the frame needs to be transferred, because it doesn't understand the information that is present in the frames, right? And it violates all the three principles or the three pillars of information security, right? So I think this is more than enough for today's class, and then you know uh, let's see what all we discussed before we conclude our class for today. So we talked about OS alias, and then we mapped it to our TCP/IP model, right? And then we also talked about layer one devices like hub and repeater, right? And then we also touched upon what is hub, right? So here we talked upon what is hub and why do we need it, and we also discussed very briefly about a repeater, and then what is the use of it, like just to regenerate a signal and then transfer it to a larger distance, because of just to prevent the attenuation or the loss of signal. So these are the hubs and the repeaters that we have in a layer 1 device. And then at last we discussed about the working of a hub, right? So how it works, how it transfers the packets, and what is that it lacks from the perspective of intelligence. And we also briefly touched upon information security pillars, that is CIA, right? So I would conclude my class here today.